let's suppose that we wanted to find an equation for this sinusoidal graph, this sine wave. What we have to do now we know we have 4 different descriptions, plus or minus cosine, plus or minus sine. We also know that we have an infinite number of descriptions, but they come in those 4 varieties. The plus or minus sine or plus or minus cosine, that's a choice that we make. We decide where we're starting our graph, where we're thinking of as starting the graph. That'll determine whether we're using sine or cosine. That'll determine whether we're using plus or minus. So let's suppose that I wanted to write an equation thinking about this point right here. I'm going to think of this as the start. I'm going to label that point A. If I choose A as my starting point, my horizontal shift will be -7. So C is equal to -7. And we're at the middle going up. So I'm going to write a positive sign. So if I think of my start at A, that is actually determining 2 things related to writing the equation. Number 1, the horizontal shift. So if we start at A, that's determining a few things. Number 1, C is equal to -7. And the other thing, since it's at the mid going up, we're going to use positive sign. So that start determines a few things. It determines your horizontal shift and which function and whether it's positive or negative. Positive or negative, sine or cosine. So when we write our equation, it's going to be a positive sign. I left a gap because that's where the amplitude goes. The period is 24, but we don't put 24 into the function. We have to figure out what B is. So B is 2 pi divided by the period. In this case, that's 2 pi divided by 24. Cancel a 2 out, we can write pi over 12. Then comes theta minus. And in this case, our C is -7. So when we have theta minus a -7, we end up writing theta plus 7. Close the theta, close the sign, and then we put in D, which is the mid, which is plus 2. We're going to write a bunch more equations that give us the same graph. The amplitude, coefficient of theta, and vertical shift will not change. Plus and minus, sine and cosine, horizontal shift, that will change. Yes. Yeah. So once we have the middle, the top, and the bottom, I've got the y coordinates all sorted out. So notice that the middle all have a y coordinate of 2. The top will all have a y coordinate of 7. The bottom, one of them will have a y coordinate of -3. Even if I continue this down, this one over here would have a -3 as well. That's how we sort out the y coordinates. The next thing is we have to sort out the x coordinates. So I just picked one to start from. So there's nothing fancy going on here. I picked this one. I just made that up. I had to pick something. So I just said, I'm going to use a -1 and it's going to go right there. So I just made that one up. The rest of them are going to be determined by the fact that the period is 24. 1/4 of the period is 6. So I'm going to have all the x coordinates be 6 units apart. So I made this -1 up. I chose that to be the start. The other x coordinates will be 6 units apart. Oh, I guess they're theta coordinates. And it's 6 because they're all 1/4 of the period apart. So if that's -1 at the top, then the middle going down, which is the next point, that's 1/4 period apart, or 1/4 quadrant. -1 plus 6 is 5. 5 plus 6 is 11. So that's how I got those coordinates. And then going backwards, I had to do -1 minus 6 to get -7. So I just made up the -1 because I had to pick something. That's as made up as the 2, 7, and the -3. Questions? Let's start at a different point. I'm going to imagine, let's start at the top up here. Since we're starting at that top point, we know we're going to be using a positive cosine. Positive cosine starts at the top. And whatever the theta coordinate is there, that's going to be my horizontal shift. Now I've got the 5 things I need to write my equation for the function. We're starting at the top, so it's going to be a positive cosine. The amplitude is still 5. The period is still 24, so B is still pi over 12. We're still using theta, so I just write theta. The function says theta minus the horizontal shift, and the horizontal shift is a -1. So it's going to read theta plus 1, but we're going to think theta minus a -1. Notice the amplitude A, the coefficient of theta B, and the vertical shift D did not change in the new form. What changed is the horizontal shift, plus or minus sine, plus or minus cosine. Any questions? Only an infinite number more to go, so we're well on our way. It'll only take an infinite. Class going to go long today. It's going to go infinite time today. I hope everybody brought a beverage. I'm just kidding. We're only going to do half infinite time. Half infinity is, oh, shit, still infinity. Maybe we'll just do 4. So if we start at C, if we start at, oh, I didn't label what C is. So that 5, 2, that's going to be the point C. What are we going to use for a horizontal shift if that's our starting point? 5. So C is equal to 5. And what the plus or minus, sine or cosine, what are we using at this point? That's the middle, but headed down. Negative sine. So we've got, those are the things that we need to know. Now we've got all 5 parts, A, B, D, C, and plus or minus sine cosine. Our amplitude is still 5. Period is still 24, so B is still pi over 12. Theta is still theta. It's theta minus, and in this case, we write theta minus 5. And D is still plus 2. It's because we're thinking about the graph starting at this point 5, 2. Question? No, the value of C is just whatever we read in that X coordinate or in this or the theta coordinate. So like at point A, C is -7 because the coordinate is -7. -1, C is 5. The next one I'm going to do is C is +11. So we just read what that coordinate is. That's what what shows up at C. But because the equation is modeled with is built with theta minus, we say theta minus C. So that's why theta minus 5, because C is 5. Theta plus 1 when C is -1. So if I label this point 11, -3 as D, it tells us two things. Number one, what is the horizontal shift? 11. +11, because it's just that's where that is. And what what function are we using? And what sign does it have? Cosine, and it's negative because we're at the bottom. So negative cosine because we're at the bottom. So now we can write our equation. We're going to write negative space cosine. Amplitude is 5. Go printing press style. We try to do one whole color at a time. C is 11, so it looks like theta minus 11. And D is still +2. If I moved on to another point, if I said start at point E at 17 that's back to the middle going up. So all I would do is go, it'll be +5 sine pi over 12 theta minus 17 plus 2. So that's how that would change. And notice that the -7 and the +17 are 24 units apart. So we could figure out where all the next points were going to be. If I wanted to write another positive cosine, right now C is -21. The next C with a positive cosine would be -1 plus 24 or 23. So I could have a positive cosine with a theta minus 23. So we have an infinite number. And there, if the plus or minus sine or cosine part is always the same, then the horizontal shift will always be period apart. Any questions? If it feels like we're really deep in the weeds in writing equations for sine waves, that's only because we are very deep in the weeds for writing equations for sine waves. But I opened a can of worms, so now we just have to have all the worms on the ground and apparently organize them into sine waves. Any questions? How's everybody okay? Right now, I'm guessing since we're this far in the weeds in sine waves, everybody's upset with me. I don't want you all looking at me all mad. That's why I took my glasses off. So now everybody looks the same. It's all blurry. So if you're like, oh, I can't even see it. You're going to have to be bigger. Think stage, not screen. Like on the stage, everything has to be big because the audience can't see you very well. On the screen, they'll just zoom in too close. And all you have to do is like make a face and like have a tear. And then I'm not an actor, I'm just guessing. I've had one speaking role. in my entire life. No, two speaking roles my entire life. We did You're a Good Man, Charlie Brown, and since I played trombone, I was the voice of the adults. I still remember my lines. It was wah, 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 wah. All right, so I have some practice for you. I hope these are almost legible. Where we do the same kind of thing. I gave you a graph down here. I'm asking you for the equation. You just have to pick one. If you want to practice, you could write 4 or more. I don't know, go crazy. At least one, at least one. Up at the top, I've given you an equation and I want you to draw what it looks like. So just use this framework, draw a nice sine wave, and then fill in 5 points. That's how you tell me where everything is. So this one's a little different. I'm going to ask you to turn this one in so I can see your thinking process, how you work through the information. So now that we've got the proper pronunciation of croissant aside, I do want to talk about the order of operations as it applies to the things that we're working on now. I just want to take this function and read what happens to theta to get the output. We want to think of a function as just a bunch of operations happening. So in this expression, we got y equals a times sine or cosine, it doesn't matter which one it is, of b times theta minus c, and then the plus d. So certain things happen. We start off with theta, and it turns into the output y. And we just want to make a list of the things that happen in the order that they happen. So if we start with theta, the first operation that we perform is we subtract c. What's the second operation that we perform? After we subtract c, what will we do next? Multiply by b. Once we've multiplied by b, I'm just going to write some shorthand for that. Then what do? We do the cosine or the sine, whatever it happens to be. So I'm going to make a shorthand. I'm going to say do the cosine of whatever or the sine of whatever. The trig function happens. Immediately after we do the trig function, what's the next thing that we do? We got multiply by a and then add d. Multiplication precedes addition. So we multiply by a. And what do we do at the very end? I spelled 5 wrong. And at that point, we're at y. That's how we turn theta into a y. So what we want to notice is that there are 2 operations that happen before the trig function and 2 operations that happen after the trig function. The ones that happen before the trig function plus c and multiply by b, those both have horizontal effects on the graph. Those both do horizontal things. See, that's a terrible way to phrase that. Both of those have horizontal effects. C is a horizontal shift. B is a horizontal squish or a compression. So here's where the trig function happens. And then we have before. And then we have after. When we make changes before the trig function, we end up with horizontal effects. So changes before the trig function have horizontal effects. After the trig function, we have multiplication by A and then addition with D. So after the trig function, we have vertical effects. The other thing that we noticed that we had previously noted is that addition creates a shift, multiplication creates a stretch. But reading the order of operations, stuff that happens before the trig function produced a horizontal effect. Stuff that happened after the trig function produced a vertical effect. So if we have addition after the trig function, it's with this plus D, it's a vertical shift because it's addition. Addition before the trig function is horizontal because it's before, shift because it's addition. Another thing that some of you pointed out was that the horizontal ones seemed to, they felt backwards. When it said plus C, things went to the left. When it said minus C, things went to the right. That feels backwards. Not all of you noticed that it felt backwards, but some of you that feels backwards. The other thing that felt backwards is that when we take B and increase B, if we make B bigger than 1, that actually creates a compression. But when we make A bigger than 1, that creates a stretch. When A is 2, the graph gets taller. When B is 2, the graph got thinner. So it's like the horizontal effects seem to have the opposite effect of the vertical ones. Stuff that happens before the function applies seem to have the opposite effect. Any questions? We can think about it changing the input. It's really useful to think of this in this context. When we have, like, say, the sine of 2 theta, that 2 means we're going to go around the circle twice in 0 to 2 pi instead of just 1 time. Think of B as the number of times we're going to go around the circle as theta goes from 0 to 2 pi. So 2 means we're going to go twice as fast around the circle. 3 means we're going to go 3 times as fast around the circle. And if we make that smaller than 1, say 0.5, we're going to go only a half a circle in between 0 and 2 pi. But this is what we wanted to think about today. It's an order of operations as it applies to trig functions. Now, the only operations that we did here were addition and subtraction and multiplication and division. We could do other operations. So other operations that we have would be like a square. What would happen if I squared the theta before I threw it in the trig function? What would happen if I squared theta after the trig function happened? So if we square the theta before we put it in the trig function, we would expect some kind of horizontal effect. If we square the trig function after, if we square the trig function, that is, if we square after the trig function has been applied, we should expect some kind of vertical change. Questions? Comments? For the rest of the day, for the rest of the math class, this is what needs to happen. We all need to have a nice bunch of points, at least 5 points. Did I say 5? 5 points labeled on the graph. I have 2 versions of it. One I wrote like as a sine, the other one I wrote as a cosine, depending on what you prefer. And I need at least one, everybody needs at least one equation for the function in problem 2. Once we have that, then we will be done. Let's copy everybody. All right, so let's pause the video here. I'm just going to sign off on the video now. See you on Thursday.